Hey everyone. So for today, I was gonna go over some algebra stuff for a little bit, and then I'll go into pre-algebra to go over some of the new material. The last little bit of the new material for pre-algebra is going to be changing attributes. Um, for today, for algebra, I am gonna go over a few IXL problems, but I'm also gonna introduce, not really introduce, but just to kind of broaden it and kind of do more of an enrichment activity, just because there's a few problems on there about perimeter, and also to show you what it would look like if you happen to have algebra tiles, which I didn't have the opportunity to put on for the notes, so we'll at least go through a few problems like that, and yeah, and we'll just go from there. Alright, so I'm going to go ahead and jump up at least another level for adding and subtracting polynomials. So for today, the first problem they want us to subtract. This is going to be algebra, but I'm going to start pre-algebra in about 25 minutes. So if you come back in 25 minutes, then I'll start on the pre-algebra stuff. So we're going to have 7m cubed plus 9m squared minus m plus 6. It would help if you could see that. So and then we're going to subtract 6m cubed plus 8m plus 4. And then I said with subtraction, you're just going to add the opposite. So I'm going to go ahead and change these signs real quick. So that's going to be a plus, minus. Instead of making this a minus, I'll just add the little negative right there, and then add the little negative right there. And then we're going to combine our like terms. So 7m cubed, negative 6m cubed, those are the same degree. So we're going to have 7m cubed minus 6m cubed. So those are done. We have 9m squared, but we don't have an m squared over there, so I'm just going to write 9m squared. We'll be done with that. Then we have negative m and negative 8m, so we'll write negative m minus 8m. Those are done. And then we have positive 6 and negative 4, so plus 6 minus 4. And then we're just going to go ahead and simplify. So 7m cubed minus 6m cubed is going to be, m cubed plus 9m squared. That was the only one. Negative m minus 8m is going to be negative 9m. And 6 minus 4 is going to be positive 2. So this would be our final answer if we were to put that in. So I'm going to plug that in real quick. Oh. Minus 9m plus 2 is a bit. Awesome. Alright, so let's try another one. And then I'm going to do some with the algebra tiles, and then I'm going to work with some on the perimeter aspect of this, because there was one question, I think, on the independent practice that had it with perimeter. Alright, so you know what, let's go ahead and just jump up another level. Alright, so we have 7t squared plus 5t plus 4. We're going to add that to 7t squared plus 2t plus 7 So this is just an addition problem. We don't have to worry about anything with changing the sign. So I'm just going to underline then in this case the like terms as we go through them. So you have 7t squared, 7t squared, we're adding them, so that's going to make it then 14t squared. We have positive 5t, positive 2t, so if we add those two together, we're going to get 7t. And then the last thing, we have positive 4, positive 7, so if we add those together, we're going to get positive 11. Now, the last thing I didn't do on the other one, which I'm sorry for not doing that, but just to kind of go over the naming aspect for polynomials, you remember you name off the degree first, followed by the term, so degree first, followed by and followed by the terms. So the degree is going to be 2, so it's, remember you go, if you have a degree of 0, it's constant, 1, it's linear. Let me write that over here. So your degree is 0, constant, 1 is linear, 2 is quadratic, that's a RADIC, 3 is cubic, and then 4 and more, you just name it off the numbers. So if it was like a 4 or 5, it'd just be, so 4th degree, 5th degree, and so on. So in this case, our highest degree is 2, so then it's a quadratic. And then for the terms, the number of terms, 1, 2, 3. Remember with 3 terms, trinomial, think tricycle, so it's a trinomial. And in terms of terms, we have one term that's a monomial. And you can think of monomial. Can you see that? Yeah. 2 is binomial, bicycle. 3, as we just said, was trinomial, so I'm just going to write tri, and tri, the prefix tri means tri, like 3. And then 4, this is when you get a 4-term, 5-term, 6-term, so 4 or more, you just use the number and then term. Polynomial, so 4-term polynomial. And then Madison, can you be more specific about, like, is it the naming aspect of the polynomials, or is it the adding and subtracting piece? All of it, just so I can kind of, that way I'm not doing too much of one thing. And sorry I didn't respond to it earlier, I just wanted to finish what I was going over for the naming aspect. I'm gonna erase this, well, all of it, I wasn't. Okay, so Monday I went over the notes. Basically, again, I know there was already a video out there for the notes of Miss King going through the notes, and I just kind of just broke it down with going through the terms. Basically, when you're adding or subtracting monomials or polynomials, you want to have the degrees the same. They're going to be like terms. And then, actually, let me just start over from here. All right, so let's scoot. Wow, this is taking forever. All right, so I'm gonna run through the notes just to show, like, go through. Okay, so big thing to take away from all of this, from what we just went, like, from what's over in the packet situation when you have the notes that I wrote. Standard form, make sure your degree is going from highest exponent value to lowest. That's the first thing. And the degree is the exponent value, so the highest exponent value. If it's just one variable, it's just the exponent that's on that variable. So like y, this is y to the 1, that means it's a degree of 1, 2, but it's also the sum of the exponents. So if you have more than one variable, being multiplied together, you need to add those exponents. So that's why yb is a degree of 2, and x to the third y squared z to the 7th is 12, because you add all those exponents together. It's all together is that degree. Then we went off of naming things, like naming the polynomial, so you focus on the degree. So with the degree, I'm going to try to scoot over, going from 0 to 4, you have constant, which makes sense because you don't have a variable that's affecting it. And then for 1, that's going to be linear, and we can think of that as like when we were, I'm going to write on this. So for linear, you can kind of think of when we were dealing with a linear equation. So like, ooh, probably should have my pen out instead of that. You can think of linear as like a linear line, like 4x plus 3. That would look like a linear line, or a direct variation would look like something like this. Constant, the other way you can think about that is if you go to, I don't know if y'all have gone over this, but maybe this might help. Let's see if I do this. Hold on. I'm going to scoot this over a little bit. Okay, so you have constant, linear, and quadratic. So thinking about these three real quick. So okay, well, let's see if this helps for a second, okay? So you have, I'm going to relate this to science. Maybe it can help because y'all are going into physics. So you have acceleration, you have velocity or speed, and then you have distance or displacement, right? So if you have a constant acceleration, that means it doesn't change. That means no matter how far you go, your acceleration is going to stay the same. And usually that's how you learn physics when you're dealing with your graph, and you'll see it something like, this is my x and y value. It would just be a straight line, okay? There's no change, there's no nothing. You could think of that like a y equals 3. Notice there's no variable there, right? Oh, it would also help if you can see that, because obviously I'm not paying attention to the coder instead of just going on my own thing. Well, in essence, there is actually a variable, but that variable is to the 0 power. And what did we know anything to the 0 power equals? We know that it equals 1. So 3 times 1 is just 3. So there's no change in this output. Okay, so it stays the same. It's constant, never changing. Then with velocity, though, it does change, because as you accelerate, your velocity is changing. That means as you are changing you're changing your speed very rapidly over time. So that means it's constantly going to be increasing. That means your velocity will change based off the time. So that means that you'll have some constant, and if this is 3, so if we're going back with that, we'll just make it simple, make it 3. So that means with time, your velocity is going to change as well, and that's how you get this linear line. So if you have a variable to the first power, that's going to be a linear polynomial. And then usually with distance, since your velocity is changing a bunch, then you'll end up getting what's like a quadratic. Okay, and then that's when you'll get something like your displacement, your distance is going to be 3 times 2. So you would have something that was raised to the second power. That would be a quadratic. And that's why you may have seen these in physics or science class, but I'm not sure. Whoops. And the naming thing is going to take some time. I had another student was having some difficulty on Monday or Tuesday when we were going through it, and it took some practice with it. So I'm going to keep going through practice problems and see if we can pick it up that way. But you need to kind of memorize these. All right. And then with adding and subtracting, we're going to keep them like terms. So what I'm going to do is I'm going to bring these this IXL down levels, and we'll start from the beginning so it's a little bit easier to pick up, because I don't want to go through the notes again if Unless you want me to, I could. But I do have a video of that when I break that, go through those. Alright, so I'm going to just look at the first polynomial, and we're going to start with the naming piece first. So I'm going to write the r squared. Okay. Well, okay. I mean, I'm still going to go through the problems, like I'm going to explain what was in the notes through the problems instead of just going through the notes again. And like I said, though, I could go through the notes again too. You just let me know. If I'm looking at this first polynomial, though, the important thing is that we need our degrees to be from least to from greatest to least. So again, the degree is the exponent value. So this would be a degree of 2, degree of 1, and this would be a degree of 0 because this is 2 times 1. That's why it's a degree of 0. Right, but we don't write r to the 0 because anything times 1 is just itself. So I'm going to erase that, okay? So if I was to name this, naming it, you're going to name it off the degree followed by the terms. Okay? So what is the highest degree in this polynomial? The highest degree is the highest exponent value, so this is 2. So going off the names that are on those notes, so if you go back to that second page where it had the little table, it goes 0, 1, 2, 3, 4. 0 is a constant, 1 is linear, and 2 is quadratic. I'm probably spelling this wrong as well. And then we name it off the number of terms. So if there was just one term, so if I covered up these first two, I'm sorry, these last two, because we're just focused on the quadratic. So if we covered up that, then it would be a monomial, just be one term. A binomial would be 2 terms. By thinking 2, like a bicycle has 2 wheels, a binomial has 2 terms. A trinomial has 3 terms that are being added or subtracted. Thinking think tricycle. So this would be a trinomial. So if we put those two descriptors together, then we have a name. You could also kind of think of this as like thinking with your classification system for animals. You have your genus and species. So you have, like, think of it like that. So this would be a quadratic trinomial, and not with the S. I was sorry about that. And then this quadratic trinomial is being added. We're going to see what would we name that. So I'm going to add that. So if I was to name this polynomial, we're going to name off the degree first. So the highest degree is 2, so that's going to be a quadratic. And then we're going to name it off the number of terms, 1, 2. So there's 2 terms, so think of like a bicycle. There's 2 wheels, so this is going to be a quadratic binomial. Alright, now that we've named them, which we didn't need to do for the assignment, but I just wanted to at least keep practicing that. When you're adding polynomials, you need to add things that have the same degree. So r squared is going to be added to 5r squared. So r squared plus 5r squared, think of it just like x plus 5x's is going to be 6r squared. Then you're going to add your 2r to your 4r. Because again, they have the same degree. So then we're going to add that, and that's going to be 6r. And then lastly, we have just plus 2. We didn't have another constant term over here, so you just write plus 2, and that would be your answer. So I'm going to plug that in. Oop. See if I get a subtraction. Okay, good. So with subtraction, I showed 2 different ways that you could do this on the video that I did Tuesday. I'm going to show both ways on here, but again, I'm going to recommend the first way that I show it rather than the second way, only because there is some confusion when you use that method, but there could be the possibility of confusion. So the first way to do it is, again, to write out your polynomials. 6f plus 3 minus 3f plus 2. Alright, so if I was to label these first, off the degree, the highest degree that we have in this first polynomial is a 1, f to the first. So it's going to be a linear. And then how many terms do we have? We have 2 terms, so that's a linear binomial. What about the next one? So the highest degree is going to be a degree of 1, so that's going to be, again, a linear. And then how many terms do we have? 2, so it's a linear binomial, because we have 2 terms, just like a bicycle has 2 wheels. Alright, now when I said with subtraction, the method that I recommended is adding the opposite, so I would make this a addition symbol. Make this a negative. Make this a negative. And then I'm going to write out how you would see that. So 6f minus 3f. 6f minus 3f. So we got those written down. Positive 3 minus 2, because it's a negative 2. Alright, simplify. So 6f minus 3f is going to be 3f. 3 minus 2 is going to be plus 1. And then that would be your answer. Now I did see another way to do it, and I'll call this like the stack method. And when I was trying to find some video resources for y'all, this seemed to be another method that we could subtract polynomials, kind of like how we did elimination for system of equations. I just would recommend being very careful when you're doing this, only because it is easy to forget about changing the sign. So I'm going to put the first polynomial on the top. That a little bit. So 6f plus 3. And then we're going to subtract 3f plus 2. Alright? So 6f, and they're stacked off on top of each other. So 6f minus 3f is going to be 3f. 3 minus 2 is going to be 1. So that's another way you can do that. I'm hoping that I can show another one where there is a missing term, or one of them has one but it doesn't have it in the other, so I can show you what you can do to substitute that. That is another way you can do that. Plug that in real quick. trying to get a subtraction one. No, guess not. Okay. I can kind of show it on this. So negative 8n plus 4 plus n squared minus 2n minus 6 So look for your highest degree. Your highest degree in your first polynomial is 1, but the highest degree in your second polynomial is 2. So we're going to write, because you always want to write in standard form where your highest degree is first, so we're going to write n squared. There wasn't anything over here, so we're done with that. Then we have negative 8n and negative 2n. We have positive 4 and negative 6. So then just simplify. Negative 8n minus 2n is going to be negative 10n. Forgot to write this. Positive 4 minus 6 is going to be negative 2, so this would be your final answer. Madison, I'm not sure if you're still here, but is that helping some with going through more problems, or? I'm just going to show another example real quick, and then I guess I'll move over to pre-algebra unless anybody else has any other questions about algebra. Just in case, just to show you the using the stack method again, why it can be somewhat confusing instead of just adding the opposite. So for example, if you had something like, let me kind of use what we have here, this squared. So the one way is to add the opposite. So you would make this an addition and then change the signs. The other way to do it, like I said, was with the stack method. So you'd write the first polynomial on the top. You're going to subtract the second. Notice that you have x squared, but this doesn't have an x squared. So what you need to do is you need to have like a placeholder for anything that you might have. So for the second one, it'd be 0x squared, because there isn't any. And then for the other one, it would be plus 0x, because there isn't a 1 degree term. And that just helps with having your placeholder so you know what you're subtracting and you don't misalign something. So negative 5 minus 0 would be just negative 5x squared. 0 minus negative 7 would be positive 7x. And then negative 9 minus 7 would be negative 16. So this would be your answer. And just to kind of check that, if we were to add the opposite real quick. So if I did add the opposite instead, so if I added opposite, negative 5x squared, there isn't one over here, so it's just negative 5x squared. Positive 7x, because there wasn't another x term in our first polynomial, and then negative 9 minus 7 is negative 16. Do we get the same thing? Yes, you get the same thing, but it's really important if you are going to do the stack method is to have those placeholders so you make sure you match up your terms, otherwise you could make mistakes or make a mistake. And then just the last thing, if you were to name this again, you name it off the degree and the number of terms, where your degree is the highest degree that you have for the polynomial, which is a 2, so this would be a quadratic. And then it's 3 terms, so a quadratic trinomial. So that would be if you wanted to name it. I'm not sure if there's any more questions. If not, I was going to switch over to pre-algebra just to cover their last little topic. Give you all a few seconds just because I know there's a little bit of a lag. But if you do have questions and you want to come back later and ask, you can ask at the end of pre-algebras as well, or email me. Alright, well if there's no more questions, like I said, if you want to ask them later, that's fine too. I'm just gonna give me a brief moment pre-algebra just to kind of switch over because I need to pull up a different whiteboard, so I'll be right back in about a minute. Alright, so for pre-algebra, I am going to go through the notes. I know you may have already had it filled out on your paper, but some were saying it was a little bit better for me to go through it with them just so they can kind of see the thought process of what's going on rather than just reading from it. So feel free to ask any questions as we go through this. So with changing attributes, what they're asking for changing attributes is asking for us to change one of the dimensions or multiple dimensions to see how it affects the volume of the surface area. So with the volume in the surface, give me 1 second, y'all, I'm sorry. Okay. So there may be a little bit of technical difficulties on just for a second. Okay. So as you are changing the attributes, we're going to see how it affects the volume. So if we were to find the volume of this rectangular prism right off the bat, volume for a rectangular prism, second time I did that today. Volume is going to be length times width times height. So if I wanted to find the volume of this, it's best to label it so you know if you have to change any of the attributes, which dimension. If you have to change a dimension, you know which dimension you're going to change. But we are going to notice something once we get through this about what's occurring, so you may not even need to label it so much as just to see what the trend is. So I'm going to label this 11 as my length. I might have labeled that as my width on the paper, so I'm sorry if it's different, but we're going to still get the same answer. 5 will be my width, and 6 is going to be my height. So if I wanted to find the volume of the original shape, I'm going to do length times width times height, so I'll do 11 times 5 times 6. And you can adjust those. Those can be in any order because the commutative property of multiplication allows us to do that. So if we multiply those all outright, you're going to get a volume of 330 centimeters cubed, with volume dimensions are cubed. And just to show you with the calculator I have up here, you get 330. Now that's the original. Now let's say though that you wanted to increase that. Let's say you had a gift and then you decided to get them something different and you need a larger box, and you notice that the length of the gift is going to be twice of what it originally was. So how would I change this length if it's now double? So if I'm going to double, remember with scale factor you're going to multiply, so with the scale factor you're going to take that 2 and you're going to multiply your length. So we're going to do 2 times 11. So my new length is going to be 22 centimeters. So this will be my new length. And now they want to see what the new volume is going to be if we have this new length. So if we bought a different gift, how much more volume is going to be needed for that box. So we're going to take, again, volume equals length times width times height, except this time we're going to use 22 for the length, 5 for the width, and 6 for the height. So if we multiply this outright, you're going to get a volume of 660 centimeters cubed. So what happened? So when we multiplied our length by 2, our volume doubled. Notice that 660 is just double 330. Well, let's see if that is the same if we were to multiply by 3 instead. So if I did the same thing, so if I started over, I decided, you know what, no, I'm going to get an even different box. I would make that new length then 3 times the original. So if it was originally 11, I want it 3 times the original. That means then my new length is going to be 33 centimeters. So then what would be my volume then if it was now 33 centimeters in length? So we were going to take, again, I'm going to write it over here too if we have to reference it later. Length times width times height. And our new length is 33, so we're going to do 33 times the width, which was 5, times the height, which was 6. So if I multiply those all together, then we see that our volume is going to be 990 centimeters cubed. And notice again a trend. As you multiply a dimension by a scale factor, the volume changes by that amount as well. Okay, so that's what we're really trying to show for all of these notes. With all of this is showing when I was writing out this key is that whatever your scale factor is for that dimension, it changes the volume by that amount. It doesn't matter if it's for the length, it doesn't matter if it's for the width, it doesn't matter if it's for the height. Whatever you multiply a dimension by, it will change by that amount. Now what that does not affect, which is what we go over at the end, is the surface area. I'm going to repeat that one more time. Multiplying by a scale factor is not the same. It won't be, you're not going to multiply your surface area by the same amount because we have addition in there, so you're not going to get the same answer as if you were to multiply with your volume. The volume, it's just you're going to multiply by the scale factor and then you're done. Alright, so if we were to do the same thing then for this shape, again, I would label your dimensions. Again, I'm sorry if they're different than what I labeled on my notes that you all have in the packet. But we can make the 5 the length, the 8 the width, and then the height 4. So if we were to find the volume, doing 5 times 8 times 4. So if we were to multiply those all together, we would get a volume of 160 centimeters cubed. Well, if we wanted to multiply that width by 2, we wanted to increase it by a scale factor of 2, we're going to multiply 8 by 2. And again, this is probably different than what it was on the notes that were given to y'all, but you're going to notice you're still going to get the same answer because like I just said, whatever our scale factor we do for the dimension, it changes that volume that same amount. So if I double this width, so the width is now twice what it originally was. So it was 8, and we are now multiplying it by 2, so we have a width of 16. How much is that going to change then our volume? So it's going to be 16 centimeters. So again, let's just plug it into our equation of length times width times height. So our length was 5, our new width is 16, and our height is 4. So if I was to multiply that, you get 320. And let's just check. Let's say, so did our volume, our original volume of 160, if I was to multiply that by 2, would we get the same answer? Yes. Okay, so notice if you change your scale factor on that dimension, it changes that volume that same amount. And again, it doesn't matter if it's for the width, the height, scroll or the length, it will always be changed that same amount. So I'm going to show you just again for the height. So the height was originally 4, but we're now going to double that height. So now our new height is 8 centimeters. So if we were to plug it back into our original, we keep our length the same as 5. We keep our width to go back to the original of being 8. And our new height is 8. So if I multiply those all together, we should get a volume of 320. Let's see if we do. So we have 5 times 8 times 8. We get 320 centimeters cubed. Alright, so like I said, whatever the scale factor is for that dimension, you're going to multiply that volume by the same amount. And you'll see that you don't even need to recalculate it, you can just multiply it by that scale factor. Before I do this last one, because this one's just building into it, I do want to show you one thing just with the surface area of how it does not affect it on this top row. So I'm going to work through those problems real quick first. So showing you how the surface area is not affected. So with the surface area of a rectangular prism, we got to remember, now this is on your formula sheet so you don't need to memorize it. It's 2 length width plus 2 length height plus 2 width height. So then again, just labeling stuff, 11 will be my length, 5 will be my width, and 6 will be my height. It is going to get a little bit cramped when I write this, so it's going to kind of run over, so I apologize for that, so just bear with me. So 2 times the length of 11 times the width of 5, 2 times the length of 11 times the height of 6, plus 2 times the width of 5 times 6. So going with each term, 2 times 11 times 5, let's use the calculator real quick to see what that is. Get 110. 2 times 11 times 6. 132. And then 2 times 5 times 6 should give us 60. And then we're going to add all these together. So 110 plus 132 plus 60, and we get 302. And with surface area, that's centimeters squared. Alright. So what I'm going to do is, now that we have our answer, I am going to erase this part up here just so we're not getting confused when I'm dealing with the new width. So I'm going to erase that real quick. So there was something there, I'm just erasing it. So now they want us to find out the new surface area after our width changed by a scale factor of 4. So we would take our width of 5, and with a scale factor, remember we multiply that. So 4 times 5 is going to be 20. So now we're going to recalculate it with this width of 20 centimeters, and not centimeters squared, just centimeters. Alright. So 2 times our length of 11 times our width of 20 plus 2 times our length of 11 times 6 plus 2 times our width of 20 times our height of 6. So trying to find what each term is equal to. 2 times 11 times 20 is going to be 440. Two times 11 times 6, 132. Times 20 times 6, 240. So if I add all these together, we get 812. Now, just to show you, okay, so with our volume, if when we multiplied by a scale factor, the volume changed by that same amount, so I could just take this and just multiply it. But if we do this with our surface area, so if I do 302 and try to multiply it by 4, we don't get the same answer. We get 812. This says it's supposed to be 1208, so it does not follow the same trend as it does with volume. So surface area is not affected the same way as volume. So you will have to recalculate it. All right, just to show you one more time, I'm going to erase this. So our length of 3, if we go back from the original, we had a length of 11, so this time our length is going to be affected by a scale factor of 3. So our new length is going to be 33. So let's try it one more time. So if we're trying to find the surface area, so we're going to do 2 times 33 times the original width of 5 plus 2 times 33 times 6 plus, write this down here, 2 times 5 times 6. So first term, 2 times 5 times 33. Oops. $330. Two times 33 times 6 is 396. And then 2 times 5 times 6, we've actually already done that. It was over here, and that was 60, so I'm just going to write that out. I know I erased it already, I'm sorry, but it was 60. So then add these all up together. So 330 plus 396 plus 60. 786 centimeters squared. So if I was to, again, just check to see if we have the same trend as volume, I'm going to show you that we don't, because 302 times this new scale factor does not get us the same answer as we did, as if we were to think of this as volume. So surface area is not affected the same way as volume. Just to kind of go over that again, just to show you what I'm talking about over here. So here, let's start with the top one. So here we multiply by a scale factor of 2. So if I did 330 times 2, 660. So volume does follow the trend of whatever we multiply by the dimension. So So 330, if we multiply by a scale factor of 3, new dimension by 3, so then our volume is going to triple in size, or amount. Now, and that is not on the notes, I'm now just realizing. So if they asked you what would be the scale factor, like how much more of an object are you able to fill in there to do that? Come on. So if you're asked to find the scale factor, what you're going to do is you're going to put your new volume over your old volume. So for example, if you're looking at your paper, I can't scroll up really easily. So on the very top bar, we had one that said, like the one we just were going over, had 990. Let's say our new dimension, our new container can hold 990 centimeters cubed when it was originally 330 centimeters cubed. How much did it increase by? You would divide those, so 990 divided by 330, and you would know that it's tripled in size. So this would be our scale factor. And sometimes you may have to simplify it to be a fraction, because you can multiply by a fraction. I know when we were dealing with dilations, we divided by the denominator, and you can do that as well. Or you can just multiply by the fraction. So I'm going to do this problem real quick, and then I'll take any other questions that y'all might have. So with this one, we have a 17 by 4. So 4 will be the height, 17 will be the width, and we'll make 10 the length. And again, if it's different than what it was on my paper that was passed out to y'all, I'm sorry. So you still will get the same answer. So if we're trying to find the volume, remember it's length times width times height, so it's going to be 10. Oh my goodness, that 10 is awful. (10 times 17 times 4). Multiply those together and you get 680 centimeters cubed. Now to show you real quick how we can do this, so if they told us that it increased by a scale factor of 1/2, our new volume should be what the original was times 1 divided by 2, so by 1/2. So we should get a volume of 340, but we're going to check that, okay? So I'm going to leave that there to save, just to remember. I'm going to write that down here. So it should be 340. So our new length, they want it to be half the original. So if our length was 10, and they want us to find half of that, it's going to go down by a scale factor of 1/2. Half of 10, so 10 divided by 2, or 10 times 1/2 is going to be 5, is going to be a new length. So let's see what we get. So we're going to have a volume equals 5. It's our new length, times the width of 17, times the height of 4. So let's multiply those. What do we get? We get 340. And is that what we got even if we just multiply by that scale factor at the beginning? Yep. Remember this, centimeters cubed for volume. Centimeters cubed for volume. Scroll out real quick. Alright, last one. This wants us to keep the length change and then increase the height by a factor of 4. So the height was 4. And they want us to increase, so multiply by a scale factor of 4, which gives us 16 as our new height. Now, if we were to take our original, this volume that we just found, and they want to then increase it by 4. Do you have a blank copy? Yes. Do you want me to send it right now? Or after this is done? Okay. Give me 1 second. Let me just pause real quick and I can send it right now. Hold on 1 second. Alright, it's sent, so it should be to you shortly. So if we were to increase the height by a scale factor of 4 from where we're at right here, that means then we would just need to multiply this, this volume by 4. So what's 340 times 4? I'm not even typing in the right spot. So we should get a new volume of 1,360, but let's see. So if our length is still 5, our width is still 17. So if we held this 5 length from when we changed it by a scale factor for 1/2, so we kept that dimension change, and then we changed our height to be 16, let's see what we get. Five times 17 times 16. Did we get 1,360? We did. So that's another. So that's just what you can recalculate it. It's just a little bit more work, or you could just multiply it by the scale factor that it's asking you to make the change from. If they gave you 2 scale factors, so like let's say they said they changed the length by 1/2 and the height by 4, you wouldn't need to calculate that twice. What you could just do is go back to your original volume of 680. So I'm going to clear all this. So they told you that you had a volume of 680 cubic centimeters. You changed one of the dimensions by 1/2. And then you also change, so you changed the length by 1/2, but you also changed the height by 4. So you could just multiply those straight across, those scale factors, and you still get the same volume. Okay, so again, you can either just recalculate the volume based off the new dimension, like we did here, or you can just multiply the old volume by the scale factor. Either of those is fine. But again, I'm going to repeat this over and over again. Changing the dimension is directly proportional. So I could multiply whatever I changed my length, width, or height by, and I can multiply the volume by that, and it will make that change. But it will not make the same change for surface area. Surface area you will have to recalculate. So if I have any more questions, this could be algebra or pre-algebra. I'll take those now. And even if you have questions later, if you're watching this video later and you have questions, you can still email me and I'll respond to those as well. Right, well, if there's no other questions, I miss you all a lot. Feel free to still contact me. And I will send out a more consistent stream schedule in the next 2 days, just so you all have that as well. And I'll still respond to questions. I just if there's no other like live questions right now, then I can go ahead and stop that for today. All right. But I hope you all have a good day and you're doing well, and I will talk to you soon.